Hello, everyone. Thanks for being here. A big thanks to EU PVSEC for organizing this industry summit. It is an honor to be here. My name is Dr. Sahar, and I'm presenting my company, Solaires. Solaires is a clean tech company based in Canada. We are developing a new solutions for harvesting solar energy. So a little bit about myself. I have a PhD in mechanical engineering and background in material science and engineering, specialized in nanofabrication. I invented a new fabrication process for thin film solar cells and transparent conductive electrodes to improve the properties of solar cells. Imagine if you could capture the sun's energy from anywhere, from windows, building facades, electric vehicles. However, conventional silicon technology is not suitable. We need a new material and technology to fulfill the requirements for those applications. Let me provide with some background context. Current solar cells are made of silicon. The fabrication process has several steps, which makes it expensive, long, energy-consuming, and produces high amount of greenhouse gas emissions. At Solaires, we make solar cells with Perovskite, which, as you know, has a much higher energy conversion efficiency and a simpler and shorter value chain compared to silicon. Our customers are thin film coaters and solar cell manufacturers who want to address market demands for flexible and translucent photovoltaic solutions with higher energy conversion efficiency. Unlike current silicon solar panels, our perovskite-based photovoltaics have higher energy conversion efficiency, a shorter value chain, and therefore lower cost, 40% lower greenhouse gas emissions, and also enable new innovative applications. Perovskite has many unique features and benefits. It can have different band gaps and can reach 50% energy conversion efficiency. It can be used in tandem structures with other technologies. Perovskite is printable on different surfaces. Its power per weight ratio is 23 watt per gram, which is the highest in solar technology available in the market. It also has unique applications such as building integrated photovoltaics, space application, IoT devices, transportations, and many more. Our first product is a perovskite-based solar ink that can be used by manufacturers to create final products, applicable to a wide range of photovoltaic devices. Solar cells consist of several layers, including the top and bottom electrodes and the encapsulation layer. Our solar ink replaces silicon in the solar module stack. And because of its high energy conversion efficiency and less energy-intensive manufacturing process, the resulting solar cells have better performance at lower cost. We have a comprehensive IP strategy that includes 44 patent families. We are projecting more than 100 patent files, including in-licensing, granted, and pending patents. Our patent applications include protecting the ink formulation, the substrates, fabrication process itself, and it also protects the potential products that can be manufactured with our technology. This is our technology stack that shows our IP strategy from innovative material all the way to the application level. Our current focus is on our solar ink. We're developing scalable manufacturing methods for our perovskite solar modules with different device structures. Our solution can be processed at low temperature and is compatible with different scalable coating processes, not to mention its low cost and low GHG emissions. Our flexible, translucent, and cost-effective thin film solar cells will enable new innovative applications for photovoltaics. We have a three-sided technology and business model that includes the development and sales of our perovskite-based solar ink, licensing our perovskite solar cells manufacturing process, and the development and sales of our photovoltaic film. Our solar ink has a unique formulation that allows fabrication of perovskite-based photovoltaic films with high energy conversion efficiency and high stability. It is easy to synthesize, and it doesn't require expensive and custom design equipment to scale up the ink fabrication. Our ink currently has a 4-month shelf life, which makes it easy to ship to our customers and store. Our solar ink has been uniquely formulated to make it compatible with most common fabrication processes, including slot die coating, inkjet printing, blade coating, and spray coating. Our team is working on sheet-to-sheet fabrication process. Our plan is to build a pilot line in Canada to demonstrate the concept of our manufacturing process. We develop all technical details and manufacturing assembly instruction with the end goal of licensing our IP to PV film manufacturers. There are very few competitors making perovskite ink. Their ink has a stability of less than a week and is also not compatible with scalable manufacturing processes. Our solar ink has a long shelf life, can be stored and used in ambient conditions, and it's compatible with different scalable manufacturing processes. About our perovskite manufacturing process, most perovskite solar cell manufacturers add a layer of perovskite to already existing silicon solar cells to increase the efficiency for resulting solar cells for the conventional market, such as solar farm or rooftops. But it doesn't solve other issues such as limited use due to the weight and rigidity of the panels, as well as the cost and high greenhouse gas emission that silicon creates. Our manufacturing process only uses perovskite that enables light, flexible, and translucent photovoltaic films for innovative applications, such as solar windows and solar vehicles. Although we are a young company, Solaires has won multiple competitions and has been featured as an emerging rocket by the investment community. There's high demand for our products, and we're piloting our solar ink with Tier 1 companies globally. We assembled a winning team of scientists, engineers, and business professionals. Our management team has the skills and diversity that leads us to innovation. We have the technology and a culturally strong team with different minds who can deliver it. Solaires is accelerating the advancement of solar technology as a major contributor to low-carbon economy. We're changing the way that solar cells are currently made, and we're also impacting the ability of women and minorities to participate in science-based industry. Solaires and its team are committed to meeting the United Nations Sustainable Development Goals. We're directly impacting 4 of them, and we're also in the process of being B Corp certified. At the end of this year, perovskite will start to invade the conventional solar market in 3 ways: in tandem with silicon, tandem with other technologies and thin films, and perovskite-only modules. Perovskite has the potential in the long run to drop solar costs by 80%. Initially, offer 33% more electricity as a cell in tandem with silicon for slightly higher manufacturing costs. Over the next 10 years, it will cut 50% of traditional solar generation costs, and it will continue failing the price. These advantages will see perovskite pass 29% of the global market by 2030. If existing suppliers do not adopt perovskite early, they will fall by the wayside. Perovskite is a new material that could revolutionize the way we generate energy. Imagine capturing the sun's energy from anywhere with light, flexible, and translucent solar cells. Perovskite solar technology can fundamentally change the way that we're making energy from sun's energy. Its beneficial properties has affected investors and attracted investors globally, and position perovskite as a game-changing front-runner technology that exceeds the performance limitation of conventional solar cells. In the long run, Perovskite reduces solar energy cost. We have started shipping samples of our solar ink. Please contact us if you're interested and if you want to get more details and if you like to try it. And make sure that you visit our showroom as well. Thank you.
Thank you so much, Mrs. Sam. I first need also to repeat my apologies that I wasn't there in introducing you.
No
there are more because I just came out from another session and the handover didn't work on my computer as I wanted. But now I'm here and I congratulate you for this very exciting presentation.
Thank you.
I think this is a big future. And it's good that you use the industry presentation to bring this forward, to advertise it. It's new that you also underline the possibility for minorities and women to work in science-based industries. And I think it's a very, very good example. Thank you so much again. I would love to run down applause generator. So you have mine at least.
Thank you so much. Thanks for having me here. It's a pleasure and it's an honor to be here. Thank you.
Okay, then we would go already to our next speaker, which is Mr. Damien Etienne. He is with Avalon.
Good afternoon.
Good afternoon. He is with Avalon from Switzerland, and he will present us a talk with the title "Accurate Industrial Current Voltage Measurement of Bifacial and Heterojunction Tandems." Right? Okay, Damien,
Exactly.
It's your floor. I'm looking forward.
Okay. Thanks. So yes, so as we are getting more and more HIT and module that has high capacitance in the market, I think that was something interesting to talk about, and how to perform the measurements as it's becoming more and more complex to measure these high capacitive technologies. So we will go through the company and myself introduction, measurement technique for high hysteresis panels, the solutions we can bring, and we also have a quick talk about bifacial measurement and how our products can help on this regard. So quickly for the company, so we were founded in 2018 with the goal to produce LED-based solar simulator. As we see, xenon, which has been the main source for solar simulator for like a very long time, now it starts to have limitation, especially in terms of pulse length, which we will see a little bit later in the presentation. That is becoming a challenge. We released our first machine, which is a very high-end system in 2019. The next one, which is technology presentation to prove that LEDs can be better than xenon. And now we just released the Nexon Zion, which is also a high-end solar simulator, but at much lower cost, which allows, to be enabled in production without breaking the bank. So we are based in Neuchâtel, Switzerland, and we also are located in Shanghai. Which allows us to be like in the main production side, but we also are like deeply rooted. Like Neuchâtel is my hometown where I'm from as well. Myself, so I'm working in the solar industry since 2007, mostly in solar metrology, and also in R&D in electronics for many things related to metrology, so acquisition, in outdoor acquisition, and things like that. I used to work for Passan Meyer Burger for more than 5 years, and then TÜV Rheinland here in Shanghai. So I'm specialized in metrology and software and electronics. Hold some patents in dynamic IV, notably, which was done with Dr. Monokroussos at TÜV, and also in some solar simulator design. And I'm co-founder of Avalon in 2018. Okay, so as efficiency of HIT increase, as do so the hysteresis effect. So we see panels now with higher and higher hysteresis effects. So it's more and more difficult to perform the measurement in a single flash of those panels, which can be challenging for laboratories, but in the laboratorial setup, you still can afford to spend maybe 30 minutes to 1 or 2 hours to measure a single panel. For production is another story. But also for some laboratories, we know when you start to have a lot of panel to measure a lot of different types of panel, it also becomes a bottleneck. So there is some methods that have been developed to measure HIT. So optimization of the applied curve, direct reverse measurement, and dynamic IV. So we'll just go through those different approach and how they work. So you can see here on the right hand side, we have an IV measurement, which is the x-axis is time, in blue voltage and current. So this is the curve optimization method. So as the hysteresis effect is lower near the ISC, so we will apply a very fast curve near ISC to then slow down the curve to measure near Pmax. This allows to reduce the capacitive effect as the voltage sweep speed decreases over Pmax. The problem of this method is you still need a relatively long flash, and also it's very dependent on the voltage of the panel, so the temperature. So if you are doing a TC test, for instance, the curve might need to be tailored for each temperature range. So this is a method which can be used, but it's not really the best way to do it. So for laboratories, it's an okay method. If you are trying to do temperature coefficients, it becomes difficult. For production, it's also something doable as long as you know what you're doing and the capacitive response is not too high. The direct reverse, this is a very good method to validate whether you have no capacitive response on the cells, on the module. The thing is that you have to be careful is you cannot just measure direct reverse and then average. As you can see the graph on the right side, on the reverse measurements, the true value is actually not the average of the direct and the reverse. So this has to be also done with a lot of care to make sure you are within the tolerance. Also, this delta can be calculated into the uncertainty budget of the measurements. Usually in the industry, especially the IEC standards, if we say like if the measurements of the direct and reverse agree within 0.5%, we are pretty confident of the measurement. Downside is it requires 2 flashes, and if the results are too far apart, you cannot just average them. So for laboratorial STC, okay. For TC test, if you're able to control the temperature very precisely, it's also doable. On production, you also it will require 2 flashes. Then, so one very interesting method that we actually developed in TÜV in 2012 is the dynamic IV. We call also, there is different names in the industry. Some other company might call it some other way. So we call it dynamic IV, where we basically apply the voltage steps. And for each steps, we wait for the capacitive response to relax on the panel. So you can see on this graph, the voltage step is changed, and then we have the current response, and then we wait until the stabilization is performed. And this method can also be applied with the other ones. So we can see here, like we scan rapidly over ISC, and then the speed of the voltage sweep is reduced over Pmax and VOC. And this allows to really optimize the curve to the capacitive response of the panel. So this is a very good method when it's applied correctly. The downside is it can be very complex to generate those curves. So especially if you have high capacitive response and your flash time is fairly short, you really have to tune this precisely to the module. And then if the VOC or the voltage of the panel changes due to temperature or maybe some changes, some variation in the cell batch, you can be off with this method. So this has some downsides. So first, this method is patented. So now there is no royalties required, but we don't know in the future. It might come. That really depends on TÜV approach. One of the issues as well is you end up with a low amount of IV points. And in some case, if you really have a high capacitive response, you might end up with an IV with maybe 10 points near Pmax and VOC. So you start to require some fitting and extrapolation in order to extract the parameters. So also it gets into some complex things again. And also to validate the method, you need to perform like direct and reverse and also check the validity of the measurement, which is quite important. So for laboratories, it's still okay in most cases, as long as you don't have like 1,000 different panels to measure. You can afford to spend a long time to measure HIT panel. When it gets to temperature controlled tests, it can start to be problematic. Like let's say if you need to do 10 flashes on your panel, then you really need to have very good temperature control to make sure you don't have temperature variation during those tests. If you only need to do one flash for measurement, it really makes life much easier in this regard, whether for labs and for production. Of course, production cannot afford to spend 5 or 10 flash per panel, and it requires the measurement to be performed in a single flash. So it's more like it's tedious to implement. More complex is the measurement process, more likely are errors to happen, whether it's human mistakes, whether it's the process itself, which may be flawed. And then you have also to consider the uncertainty budget calculation, which becomes also more complex to do. So also, of course, for temperature-related measurements, the voltage of the panel will change with the temperature. So if you have like specific curve optimization you have done, like it will change with the temperature of the panel, which is also problematic. So it requires skills, it requires time and complex methods, which some lab can do it very well, but it requires a lot of manpower to perform those measurements accurately. So what if there was a better solution? The better solution is very long pulse solar simulator. So what is very long pulse? From what we've developed, that's the difference between xenon and LEDs. Xenon, as you increase the pulse length, it's very difficult to have a stable spectrum. And also you have limitation in terms of the lamp lifetime. So you have a spectral shift and the lamp lifetime itself, which are not a problem with LEDs. So with LEDs, you can potentially almost go to steady states depending on the design. However, you don't want to have steady state for this kind of measurement because you don't want to have heat injection into the panel. So you want to have a stable temperature. So we developed a solar simulator, which is LED based. We call it the Nexon Zion. And this is a 500 millisecond pulse solar simulator, which really helps to perform the measurement of those high capacitive panel. So it's a A+ rated, and it also has a spectrum which is have a spectral deviation equivalent to most stable type solar simulator, which are xenon based. So it matches quite good to the xenon systems. So here you can see a measurement. So this is implementing dynamic IV, but instead of 10 or 100 milliseconds, it implements it over 500 milliseconds. And as you can see, with 500 milliseconds, we don't need to perform any curve shaping. We can just apply a normal curve with the voltage steps. And in this example here, we have like 100 points. And this is one single flash. So with 100 points, it allows to have enough points on the IV to avoid any sort of interpolation or special filtering of the IV. And also, we don't need to perform any curve fitting or preparation before the flash. We just need to set a starting voltage and then apply the curve. So this allows to be also future proof. I will show on the next slide. It's like level of complexity to perform the measurement is much lower and also require a single flash. So this is one panel that was provided to us. It's one of the most recent, most capacitive panel you can find on the markets. So we can see here, this is the different steps of the voltage. So here you see the current change over the different voltage steps and the stabilization required. So in this case, we require about 2.5 milliseconds. So this is around Pmax. And we can see with 500 milliseconds, 100 points, we can have up to 5 millisecond stabilization points. So here the software will compute which point is actually chosen. So we can see in blue, for instance. So we can see here we have way enough stabilization time. So this is quite future-proof, and also we have a clear visual feedback of the selected point. So we can combine this dynamic IV in reverse. So the point we've seen before, the near Pmax, direct and reverse measurements. And then we can plot both IV curves on the graph. And this is the result we got for this specific panel. And we can see that we are in accordance within 0.1% between direct and reverse without having to perform any sort of fitting. As you can see, this is the IV, the resulting IV with 100 points. So we have very good accordance between both direct and reverse. So that's the advantage of having very long pulse, 500 milliseconds. It's very simple to perform. The measurement can be validated to be free of hysteresis effect by performing a simple direct and reverse measurement and comparing the results. It's very easy to implement in production. No need to perform complex interpolation or curve shaping, and it's foolproof, and of course works for big panel size. So also for laboratories and production, it really makes the measurement much easier than having like 10 or 100 milliseconds solar simulator. So typically we had a customer trying to measure HIT panel and they could not perform in the standard xenon system. That's a big advantage of LEDs. So just make your life easier. Now we can also talk quickly about bifacial measurements. So there is new standards on the IEC for the bifacial measurements, and so bifacial measurements in production can be challenging for reason we will see later. So what is performed currently?
You have a maximum of 1 minute still left because you are
okay. So
the next speaker.
Okay, maybe I will skip.
But tell me something about IEC.
Sorry. Yes. So just emphasize that on the bifacial panel, you do have defects on the backside that changes in production. So you cannot just apply a bifacial factor in production, as this is not like a static thing over panels. So it's important to measure bifacial, both rear and front in production, and that we also can provide this solution with the Nexon Xeon dual source, which is affordable. So yeah, so thank you for your participation, and don't hesitate. Maybe you have no time to take questions. I'm not sure whether I have time for question or not.
No, I'm afraid that's not possible. Okay. Because we want to keep everybody in the loop, and we have a very, very strict endpoint of the session, because then the streaming just switches off. So I thank you again, and I feel somehow very much touched, because I was in this problem of the capacitance some 25 years ago, and I'm looking forward to see this maybe coming into an IC standard. So thanks again. And now let me call Professor Dr. Stefan Bergfeld, right? Yeah, he's with his company Bergfeld Lasertech GmbH from Germany, and he gives us a presentation on flexible R&D laser systems for organic PV, perovskite, and battery research for Glovebox and air. Okay, combining everything. Professor Bergfeld, it's your floor. We're looking forward.
Thank you very much. Hopefully you can hear me.
Yes.
Very good, because sometimes the speaker are not so much connected. Well, thank you very much for having the opportunity to give this talk. The main thing what we are doing is actually R&D laser systems. So we are working on a lower technology readiness level. It's research development, maybe pilot production. So we are focusing on researchers and startup companies. The main thing, or the first project where everything started, was a first system for perovskites. It is 2 years ago. Actually, was the first project of the company. The company becomes right now only 3 years old, so very young company, and we made a system for, I can mention that, for the KIT, and with our system they get quite decent efficiency on the module level. So they made with our system laser interconnection of PV modules from perovskite. Well, and we do it in a quite different way. I was building before, when I was in the industry, laser systems also for PV, for mass productions, and we had also always problems to make laboratory systems. A laboratory system usually needs to be very flexible, maybe not that not with high production, but flexible. And researchers should change the system itself, because mostly they don't know what they probably need in 2 or 3 months, because it's depending from the results. So I always was thinking, yeah, take it around and optimize everything for research systems. Well, and the other problem what the machine makers usually have is one system is quite expensive, but for one application you always need maybe 1 or 2, at least not more than 3 systems, and then the labor costs are very high. And then we solved it to modulize every subcomponent of the system and combine it to new systems and applications. So we standardize every component, and that makes it faster. The systems are more stable, and we can implement more commercial available solutions. So we do it somehow in a different way. Let's go a step back. I'm also working on the University of Applied Science in Aachen. Actually, it's in Jülich, next to the research center in Jülich. And there I also have labs. You can see it here. And there we do projects, also public funded projects. But we, of course, cannot do delivering machines, delivering components, give guarantees, and hire actually experts at subcontractor and so on. That's everything done by the new company Bergfeld Lasertech. So first of all, I will start with actually two products we have. One thing is the Glovebox system. You can see here. So the laser part, hopefully you can see the mouse. Actually, the laser part is here in the Glovebox. And this is a part of the sample. And all the optics are here under the Glovebox. I don't show everything, otherwise also some other machine makers would be interested in that. So all the optics, beam shaping, and so on is under the Glovebox. You can have access just from the air. And inside of the Glovebox is a laser class 1 system. So you don't need any goggle, no laser safety stuff, as everything is built in. This is actually a window. And here inside of the Glovebox, you can do different laser processes. This is a box in a Glovebox, and of course we want to save nitrogen. Nitrogen is quite expensive, but for laser processing we need a strong debris extraction system to get everything clean. So we made a system where we reuse the nitrogen. So we have inside of the box, there is even a shielding to get very fast flow of nitrogen. And then we filter it outside and we go back into the Glovebox. Well, I said it is a flexible system. Actually, it's a system with 3 wavelengths at once. You also could use different lasers, but here you have 3 wavelengths at once. And also built in is a quite precise vision system. I will explain later as a module. We actually can apply to every system, not only for the Glovebox system. And also it could be with different inert gases. It could be in argon and so on. Since we have no electronic nor special electronic components or optics inside of the Glovebox, we are quite flexible with that. Yeah, here you see actually a view inside of the box, and here more detail that here the sample is in. Of course, you can do height adjustment and these kind of things, and can process the sample. And so maybe it's easier to show this one. Again, this is inside of the Glovebox. This is outside of the Glovebox. This was before we closed the Glovebox, actually taking this picture. And then here, see window, and you can open it, and then it closes actually the beam parts, and it's safe by itself. And here there's another picture. You see, we are using just optical boards everywhere with these 25 millimeter matrix. So you also can add some things in it, or you also can change distances and so on, or we easily can change the lasers, scanning systems, optical systems, illumination systems, whatever. So it can actually grow with the applications. This we have actually already. And then the second one is a more cost-effective system. Actually, the first one is also very cost-effective, but the next one is also based on these kind of modules, working on air. And here it's a desktop system. And again, everything is made with aluminum frames, so we can develop it very fast. Sometimes we ship a system in 2 or 3 weeks. Also, laser safety is built in, and we can exchange easily all the lasers. Can implement different sample holders. It has a CE certificate, which we actually make with safety stuff, that you can easily change the system without losing the warranty or losing the CE certificate, because the laser itself has a system which is safe itself. The only thing what happens if you do something wrong, maybe your sample will not be processed at the beginning. But for safety reasons, you can do it. And here are just a few applications. One thing is for thin film PV, scribing or monolithical interconnection. This is a thin film silicon, because this is mostly processed on air. It fits better than the Perovskite. Or here, this is ultra thin glass, which sometimes is used as a substrate for flexible solar cells or as a cover for flexible solar cells. And here, this hole is for contacting them. So you can contact the solar cell. or even other things. Well, I mentioned we build everything out of modules. So we don't put maybe 500 engineering hours on a project, which is built only one time. So I need to present some of our modules. And the variation and the numbers of modules also are will be extended. One thing is, of course, the laser. Sorry for that. There are many lasers, but it's right. We have many lasers in our lab. We also can give some of these lasers for rent. And this is also one module. We can put different lasers in it. Usually we are taking we like to take small lasers, air-cooled lasers, then you don't need a water chiller, but also with water chilling works also. So many lasers. We can change, or you can change even, by having the rest of the modules almost the same. The other thing is, when you do research and you want to process sample, you sometimes have only one sample, and you don't want to destroy it. So we have special, we call it through the lens positioning system, where we have for instance, a Galvo scanner, and we look with the camera exactly in the same direction where the laser goes, where the laser beam goes, and then we can do finding fiducials or whatever, and can put the next process of the laser beam in a precision of something like 4 micron to that what it was before. In production system, you probably have a camera looking from the side, but then you have a parallactic error, and then probably you are losing the first samples or the first 10 parts. But for research, sometimes you don't have so many samples, you have maybe one, and this should be good. So we are going this way. This is a module we can implement actually in every system. The other one is we always work multiple beam, multiple wavelengths. So you can do also multiple beam and multiple wavelengths processing with laser scannings. We also have XY stages. That's the same. And this is sometimes very nice. So you can do, maybe here it's an application for photovoltaics. You can do different process at once. Here it's shown P1, P2, P3. You can do at once. Of course, you need 2 printing steps for another interconnection. But this is very precise. This is precise over the whole working area within less than 1 micron. And then you also can skip all the recognition systems to find the P1 while doing P2 or so on. And you actually have 1 systems for 3 processes. And of course, you can change for each beam the distance, the focal diameter, and also the focal distance. So actually we go with different beams through different optics, and then we are combining them before going through the focusing lengths. Well, on the other module is always sample handling. Of course, we have holders for glass samples, for flat samples, and of course, and quite new is roll-to-roll, because in some cases, especially in perovskite, but also in battery, people want to process already roll-to-roll in the lab. Here it's an example for the battery, and sometimes if you want to make a battery cell, you sometimes need more than 50 electrodes, which need always the same, and then even in the lab you do roll-to-roll processing. We are using here also a Galvo scanning system. It could be different, but then with a special software which can do it quite precise while processing on a moving web. So it doesn't need to stop necessarily.
Professor Bergfeld, I need just to remind you, you have a maximum
1 second.
of a minute. 1 minute, yeah. Okay.
So these are the modules. It also, I show you just 2, which is also roll-to-roll nice. We have 3D laser scanning, which many people do have. And very nice in roll-to-roll is you can process on a drum. And this is quite precise because the web is very stable. And you keep the focus on this cylinder. And you can do it non-perpendicular, which is quite clean because the laser debris goes into this direction. here I have a lot of other applications and so on, but I think the time is over. Thank you for the application. Sorry, it's sticking. Thank you for the attention. And if you want to visit us, we are based in Aachen, Germany, next to the border to Belgium and Netherlands. Thank you very much.
And thank you very much. I just want to point out also to those people listening to your very interesting presentation, everybody has a possibility to make an appointment with you. You know, that you can go in the chat room and then
nice.
answer other questions. And so it's also, again, repeated to the audience. You have a possibility to break out and then make your own meetings. I found your presentation very interesting, but we need to keep the time.
Of course.
Thank you again very much.
Thank you very much.
And we go a little bit further away from Aachen, I'm afraid, to Saudi Arabia. It will be a presentation of Dr. Faisal Wali. He's with the King Abdullah University of Science at Saudi Arabia, not too far away from Jeddah, I think. And he will present the activities of the solar center there, I think. Dr. Faisal, it is your floor.
Thank you very much. My name is Faisal Wali. I'm Strategic Partner and Operations Manager working in KAUST Solar Center. I'm sure that you are wondering that where is KAUST and what is KAUST? So we are a university which is located in Saudi Arabia. I know the first thing when you listen about Saudi Arabia, you think about desert, which is not true in our case. We are located next to Red Sea. It's a beautiful campus which offer degrees to master's and PhD students. It's an English language university. It's also graduate research university, so focus is really on the research. But as I said, we offer the masters and PhDs. So we have more than 15 programs of engineering programs in 3 big divisions. When it comes to research, university is very much focused and on the research side, and they are having right now 11 different research centers. Today, what I'm going to talk is only one research center, which is KAUST Solar Center. I think KAUST Solar Center is something which is very close what EUPV conference is all about. Our vision is we would like to be a leader in research and development, making it sure that we are not doing only the base fundamental research, but also take the translating science into real applications as well. For this, our mission is we want to create science and technology in the field of solar energy, making it sure we do some interdisciplinary research, but at the same time, we want to train the people and bring the innovation for the benefit of the society. Having this big vision and mission, of course, we need some diverse team to deliver. And when it comes to diverse team, we are trying to cover the whole value chain of solar. And we start with material development, where we have a professor like Vincent Tung, who comes from US. Our center director, Frederick Lecoy, he came from Germany. He's our center director as well. Daria Baran, she's working on processing and upscaling. And then we also have a faculty who are focusing on device and prototyping, which includes Stefan, Thomas, and Chulu. With all these, we of course need computation as well, where we have Udo supporting us as well. These people are focusing more on a research, and to support these people, we have a team of more than 130 people in center, which includes postdoctoral fellows, PhD student, research scientists, and staff scientists, which are working in the center. So focus of the center is 2 big sides. One is the photovoltaic side, where we are looking into organic, inorganic, and hybrid PV materials. But the other side is also to go a little bit more outside of the PV and look into how we can work on photocatalysis materials and convert, which we call solar fuels, to directly on water splitting or CO2 reduction purposes as well. When it comes to main projects of the center, our focus is more towards solution process photovoltaics, and then also addressing some high efficiency of perovskite PV using the tandem as well. Other than, as I mentioned before, their focus is also on photocatalysis processes for water splitting purposes. And we also want to work on organic photovoltaics to make it sure that we increase the efficiency, either using single or multi-junction approach. To do these all things, we definitely need some world-class facilities as well. And right now in the center, we are very lucky to have 3,400 meters square area of the lab space, which include specific labs as well. For example, we have a device preparation lab, which have more than 30 glove boxes at this moment, which are full of course, equipment as well. And then similarly, when it comes to organic photovoltaics, we have a dedicated lab of organic, and we are very proud that we are the only probably center which has a very specific perovskite processing lab as well, which is dedicated because of the contamination issues, which are somehow connected with perovskite. We also have clean room areas which help us to work on the silicon side as well. We have laser labs and surface analysis lab as well. And also we spend a lot of energies to make it sure that we give a practical training to the people. For that, we have what we call our educational lab as well. Not only because, as I said, we are in a very ideal location at the moment where we are exposed not only with the sun, which is a good thing, but also with a harsh weather, which means that we have challenges like a high temperature, high humidity, and then also you probably heard that there are a lot of sandstorm here as well. So it will be quite interesting to see that how the developed technologies are performing in this harsh environment. But at the same time, we are also trying to see that the cells which we make, how they are performing in this harsh environment. For the developed technologies, we definitely need some partners, and we work with some of the companies which shares their panels with us, or they are specifically interested to do some specific research. We are working with them, but we also try a lot to see how our perovskite or tandems are working in this environment. Other than this, center is also quite successful in making some spin-offs as well. And one of the spin-off which is doing quite well at the moment in this region is Iris. Iris is offering a unique solution which is based on transparent solar windows. And this solution is quite successful when it comes to some of the greenhouse technologies in the kingdom, because they would like to see the sun, but at the same time, they don't want the infrared. So I think there is some success story when it comes to Iris. The other thing which was developed inside the center as well is, again, a solution for the greenhouse. This is retractable solar panels. So we have the solar panels which are laminated in the plastic covers, and they are moved like a curtains. So whenever farmers need the curtains to be removed, these panels are moved away, and whenever they need the curtains, these curtains will start generating some electricity, which is useful to have a greenhouse. As I mentioned in the start, that center's focus is also to provide some trainings as well. And when we are in the kingdom, we would like to focus a little bit on making it sure that we will have practical training for the engineers who are there, who wants to work in the PV field. So we organize some summer and winter school as well. These summer and winter schools are also open for the students as well. In fact, our summer school is heavily filled by the internship students from Europe. So if you are a student and you are listening this presentation, maybe this is a chance here for you as well to be part of this summer school as well. Of course, the student expenses will be covered by the center. When it comes to science or research, we definitely look into the measure that what is the number of publications and how what is the impact of these publications as well. So I think on this metrics, we are doing pretty well as well. We are increasing the numbers every year, and we are also targeting towards achieving more high impact research publications. Other thing I think center offers is the patent technology, which are being developed here. We are quite active in this. We also consider that we are contributing to the PV world with the graduate students and also providing successful training to our postdocs as well. These PhD students and postdocs right now are working in some big companies and universities at the moment. We are very open to work with industry, and at the moment we are connected with a number of industries locally and also from Europe. Some of the companies are also from Europe. So if you are an industry and you are thinking that there is something you want to work with Solar Center, we are very open for this. Why do you want to work with Solar Center? I think it is important. All the presentations are very much focused on the what's going on in Europe, but I think you need to know what's going on in the Middle East right now as well. So at this moment, in 2018, Saudi Arabia announced that they want to have a lot of investment in renewable energy sectors. So in 2018, they started a project of 300 megawatt, which was completed within 1 year time. And they have 300 megawatt already PV electricity, which is connected to the grid. And then last year, they awarded around 3,000 megawatt projects to the industry. And this was these projects are in process at the moment. As we speak, they are doing some bidding of 1,200 megawatt electricity projects again within the kingdom. So kingdom is right now, in terms of photovoltaics technology or in terms of solar, is really booming. And this all thing goes to the Vision 2030. Vision 2030 would like to achieve in total 60 gigawatt electricity using renewable energy sources, from which 40 gigawatt will come from the solar. From the morning, I'm seeing that everybody talk about 40 gigawatts electricity for the Europe till 2030. But I think you need to know that Middle East, which has no industry established at the moment, or they are establishing localized industries, there is a big opportunity available as well. So being a solar center or research-oriented center, we are in this region and we are taking this opportunity quite well. We are trying to work with the government organizations to see how can we be part of this Vision 2030 as well. We can train the people to feed their local industry the manpower, but also we can help the kingdom in establishing new standards and specifications which are required for this region. So why we are on this platform today? I want to reach to the students who are interested to do some kind of internship, or if they have finished their bachelor or master's and they are interested in pursuing a PhD degree or a master degree, then they can also approach us. If you are a graduate student who are looking for some exciting research projects, yes, we have a number of postdoctoral fellow positions as well. We are also looking for some good research scientists. If you are earlier career researchers and you would like to see you want to develop your own group in PV systems, and you think that there has to be some opportunities for you, yes, you can reach to us as well. If you are an established faculty and you want to do some collaborations with us, we are also very open in terms of this. And the last but not least, if you are in industry and you are interested to see that how your products are going to perform in a harsh weather like Middle East, or you can do some, you are interested to do find some answers to your specific research questions, we are there to help you. Also, KAUST is quite open in terms of if you would like to have your presence in the Middle East. KAUST has the setup where they can offer you some office and lab space. We are also interested to see with industry that if they have some hiring requirement, we will be able to address that as well. At the end, I want to say that we are on social media quite active. You can see us on Facebook, Twitter, or LinkedIn. And I will be there to answer your questions. Thank you very much for listening to me.
Thank you. And you have been almost perfectly in time. So my compliments. It was very interesting, and I hope that we find enough students or interesting partner for you to go into this nice university. Thank you again. So this brings me to our very last speaker, which is Andrew Barry. He's actually working in China at the HQTS group, which stands for, I think, High Quality Testing and Services. A little bit like the TÜV Rheinland, I have the impression, in China. He will give us a presentation of the quality control and assurance for PV power projects at HQTS. So I show here my watch, which I'm going. So we have to finish sharply at 16:30. So you have another 40 minutes now. Andrew, it's your floor. Thank you.
My name's Andrew Barry, and I'm a consultant for HQTS, speaking from Scotland. Today, I'm going to be talking about how quality control inspections and assurance can help photovoltaic companies around the world. HQTS started in 1987 as a government department to support clients such as BV, SGS, and Interdec to navigate effectively within China. HQTS later became officially privatized in 1995 and has grown to become a globally recognized company. HQTS as an organization is recognized as a leading third-party quality service provider in Asia. We have offices located in all major sourcing and production regions, including Vietnam, Bangladesh, India, China, and South Korea, among many others. We're dedicated to solving supply chain quality issues for large and SME clients. We at HQTS also provide a one-stop, fully customizable quality service, covering many industries such as consumer goods, industrial, energy, food, and agricultural, across a range of services, which include supply chain, management and monitoring, product inspections, testing, audits, government COC and COI certifications, and consulting and training. There's several reasons why working with HQTS can be a fantastic experience, and they can be broken down into these 5 sectors. Now, the first being a fast response time. Now, we provide fast responses to all inquiries and issues, and usually provide reports within 1 working day, with a previous notification of 2 working days to be able to deliver that. Secondly, we are flexible and agile. Now, we have a flat management structure, which helps us make instant decisions and become responsive to customer demands extremely quickly. Now, thirdly, we offer a competitive price and very customized services. Now, cost-effective services based on a global service network of in-house inspectors and experts. As well as this, we provide customized quality solutions to meet what clients truly need for their specific business. And fourthly, we are a strict and honest organization. We are a systematic and well-regulated organization that has a strict work ethic that provides an honest and reliable workforce, making sure that our results are truly what is there. Finally, We have a large global presence. Now, we're an Asian company with strong inspector, supplier, and government connections on the ground. As well as this, we've worked with thousands of large Western organizations and government bodies providing quality assurance as a third party. We have a massive reach. We provide quality assurance all over the world. Now, this includes over 50,000 global clients, 2,000 professional engineers, and over 80 global service networks, with a strong presence in Asia. However, in recent time, we started making a move more to the West, and more specifically within Europe. We at HQTS have several certifications and are part of many associations around the world. Now, these includes being the Vice Chairman of the AQSIQ Standards Committee, the International Federation of Inspection Agencies, Toy Industry Association, just to give you a few examples. As well as this, we have certifications against CNAS, against iOS 17020 and ISO 17025, and many, many more. Many of our personnel here at HQTS have several qualifications. Now, these include the KAUST, PVSEC, and Saudi Aramco Certified Inspector certifications. As well as this are members of the American Society for Non-Destructive Testing. Now, this means that the people that work here have a lot of knowledge in the field. The services that we offer to the solar industry can be broken down into three main areas. This includes procurement and supply chain management services, inspection and testing services, and certification, training, and consultancy services. These are our three main areas. As well as these, however, HQTS offers a wide range of services through the whole supply chain, such as supervision and monitoring, on-site inspections, port and container loading supervision, PV testing, visual inspections, standard testing conditions, and packaging and drop testing. To give you an idea of what our typical on-site inspections actually consist of, is that we break it into four main factors. Now, these include a PSI release inspection, FAT witness testing, TPI verification, inspection, testing, and certification reports, and finally sampling checks, to give a robust understanding of the quality of the goods throughout the whole of the supply chain. Now, to give some case studies of how we at HQTS have worked with a range of different clients on a range of different projects as a third party for quality assurance. Now, this client, who you see here, was based out in Europe, and they supplied cleaning robotic arms. Now, HQTS was brought as a third party to provide mechanical inspections for these. Now, this included mechanical and electrical inspections, including visual inspection, packing and marking verification, dimension verification, and document review. So basically, we had a look at the dimensions and if that was actually up to the requirement which was needed for the client. It's a great example of how we work in with the solar industry to provide quality assurance. Also making sure that it works as intended and ensuring that it complied with European marking and packaging specifications. Another example of how we worked within the solar industry is with one of our clients in China, where we provided pre-shipment inspections for solar panels. This included a range of different things, including a visual inspection where we looked for possible external defects such as glue marks and scratches to make sure that they were working as needed. As well as this, we also provided electrical testing to determine the capacity and conditions of the solar panel to make sure, again, it was working as needed. Finally, a packaging inspection, including a drop test, is carried out to ensure that they are all fit in with regulations and not dangerous for use. Our final case study today is based on a supplier audit for solar panels, which we provided for a client in the Middle East. Now, this included going to the factory where the solar panels were actually manufactured, then providing an audit in which we inspected the legal and technical conditions of the factory to ensure that they were adequate and fitting in with the client's requirements. In this specific case, there were some discrepancies, so we at HQTS will have submitted a non-conformity report where we explained this into detail about which items didn't actually comply with the required conditions, which therefore the client in question was able to get a much better understanding of if the capabilities of the factory aligned with their specific requirements, as well as providing a range of different quality control services, as you saw from the case studies. We also provide consultancy and training services, which includes design audits, cost control, calibration inspections, non-destructive testing, personnel and technology, and relevant demand for material technology to help give our clients a better understanding of these subjects. As you can see here, these are a list of our most recent clients. Our portfolio has companies from all over the world, from Europe and Asia, that need quality control needs regarding specifically inspections, audits, and the testing of PV products. Some of these clients include FTC Solar, Renew Power, Jinko Solar, and Juniper Green Energy. These are only a few of our most recent clients. This concludes.
Okay, it seems that the video came to an end, even though it wasn't really looking like this. As you have certainly noticed, this was a video. I wasn't quite aware of that. But I think it was very good and very interesting. And now we have Dr. Faisal Wali and Dr. Sahar Solaires here. Very good that you stayed until the very end. We have a minute, and just for my curiosity, how do you think this format of presentation fits your needs? So Sahar first, because you made a quite interesting presentation there also.
Thank you so much. Well, I would say that if I want to compare it to in-person kind of a presentation, it's definitely lacking several things. It is less interactive, but since about 2 years ago, we're kind of like, I think everybody got adopted to using online platform for, even if there's like questions, now everybody's like comfortable like typing their questions. And
could you make an appointment in the chat room with somebody?
I couldn't. I actually was looking for the features when you mentioned.
Okay, maybe we need to advertise that better. Yeah, okay. And Faisal, your impression, because you are out for getting students in university, it's clear, and I think a lot of people are watching that and want to have now more information.
Yeah, I think overall, for me, I think maybe from last 1.5 years, we are doing these online sessions, and probably we are getting a little bit used to it. But again, when you see the people in front of you, you know that where to focus now. If the students are more, then you can talk more about students. if the industry people are sitting, then you can focus. I think you can change a little bit the style or the points where you want to focus. And when you don't know who are the audience, then it's a little bit tricky.
Yeah. You don't know whether you get them or whether you lose them. I know when I'm on a podium and you see all these faces illuminated by the screens of a smartphone, then you know you lost them. But here, I think we later will get the figures. I think you did a very, very good job. I found it very exciting. For me, it was also relatively new to go through this type of presentation. I think we will need to extend. This is certainly nothing compared to a real exhibition presentation or anything else, but it's the best what we can do. So I take it also as a message to see that we advertise more, that people can get in touch with you directly. You can book this directly within the frame you're working on then. And so I wish you still a nice day. I think it's a little bit later in for you, Faisal, and relatively early still for Sahar.
Yes, the day just started at 7:30 a.m. for now.
Okay, fine. So you will have a nice coffee and breakfast, I hope. And I hope to see you again at the EU PVSEC, which, as you know, the next time will be a World Conference.
Perfect. I can't wait for that.
Okay, goodbye and have a nice one.
Okay, thank you so much.
Bye-bye. Thank you.